Hi, we are going to review quadratic functions, 2.1 quadratic functions. At the top, quadratic function ax squared plus bx plus c. Remember, a can't equal 0, otherwise it's just a line. In our book, which might be different from depending on where you came from, standard form of a quadratic is this form, a minus a times x minus h squared plus k. You might know that as vertex form or graphing form, but it's important to know that our book is going to call that standard form. So when you see directions that say standard form, they are looking for what you might think of as vertex or graphing form. You can easily see the vertex when it's in that form. Opposite of the number in parentheses is the x value of your vertex, and k is the y value of your vertex. So there is a review of completing the square there. Depending on who your teacher was, depending on how you learned it, you might have used a box. I know if you were in my class, we used a box. This number 16 would have been in the box. And instead of minusing it, that's what they did right here, opposite the box. In my class, we added it to that side. And then on the next step, you ended up minusing it over to the other side anyways, which is what this is showing. I'm going to do it the way I've always done it. You're welcome to do it anyway. We are going to rewrite that quadratic in standard form. So I like to switch it to y when I'm doing my work, just because, I don't know, it's less writing, right? F of x is 2 letters and 2 parentheses. Y is just a nice little y all by itself. I'm going to leave some space there. You cannot do completing the square if that number a is not a 1. So we need to factor that number out front. So we need to factor 2 out front. When I divide 2x squared by 2, I get x squared. Now I'm looking at this number. When I divide that by 2, I'm not going to have a calculator, and decimals get messy, so I'm going to leave it as 3 over 2x. And then this is where we end up adding that square. It's just a place saver. I'm going to add something to make that a perfect square trinomial. I leave that 5 alone. Notice I did not take the 2 out of the 5. The constant stays just like that. And now I'm going to work on the gap on the left. So to keep this equation balanced, because I factored the 2 out, right? Multiply by 2, you get 2x squared like the original equation. Multiply by 2, you get 3x like the original equation. Technically, I would multiply this box by 2. So I need to add 2 of those boxes. Kind of small, but you get the idea. On the left to keep the equation balanced. This is all just the setup. Now let's work on actually getting some numbers. So I'm going to leave a blank again. The 2 just comes down. This is going to turn into a perfect square trinomial. This is review of completing the square. I'm not going to get out tiles or anything like that. If you don't remember this, feel free to come in and get some extra help or maybe ask a classmate. But this is the bare minimum review right now. So it's always x, right? Because the only way to get x squared is if that's an x. Then, if you remember from completing the square in integrated 2, you take half of the middle term. So it's already 3 halves. If I take half of that, it's now 3/4. Then to get the number in the square, and this is part of why we make it a square, you square that number. 3/4 squared will give me both boxes. When you square a fraction, you square the top and the bottom. So 3 squared is 9, 4 squared is 16. So our box is 9 over 16. Now, don't forget the 5. Bring down the plus 5. That doesn't change until the very end. Now I'm going to do some math on the left-hand side. I have 2 times 9 over 16. Well, that's 18 over 16, which reduces. Or you can do it quicker. 2 goes into 16 8 times, so it's 9 over 8. However you get there, it definitely reduces to be 9 over 8. Then finally, I don't want it to be y plus 9/8. I want it to be y equals, or even more importantly, f of x equals. So my last step is going to be to subtract that 9/8. So now that I'm on my last step, I'm going to write it as f of x because that's what it was originally. F of x in what our book calls standard form is going to be 2 times x plus 3/4 quantity squared. And now I need to do a little math over here to figure out what minus 9/8 is. Anytime I need to do some scratch work, I just write aside. I'm doing 5 minus 9/8, common denominator, times 8 times 8. So I'm really doing 40/8 minus 9/8, which is going to give me 31/8. So this is, again, what our book calls standard form. And then you should be able to quickly tell me what the vertex is, now that we did all the hard math. It says plus 3/4 in parentheses, so that means negative 3/4. And then the k value, the constant, is 31/8, so that is the y value of our vertex. There you go. Don't be surprised to see fractions on the test, so make sure you come back and practice this problem if you need a little work with your fractions. Okay, let's try another one. So this one, you're going to get even more fractions. Well, not more, but the same amount of fractions. So why don't you pause the video and see how far you can get with this one. At least try setting it up and taking that 3 out as a GCF, and then check and see if you set yours up the same as me. So when you unpause the video, I will have set up my completing the square equation for this problem. Okay, so check your setup with mine. Hopefully you factored the 3 out. When you divide by 3, you get 7/3 in the middle, negative. Hopefully you remember that you have to add 3 times whatever number is in that box to the left to keep your equation balanced. And then keep going if you can. Pause your video again and see how far you can get. Okay, so when I go to complete the square and I divide 7/3 by 2, it's already being divided by 3. So if I divide it by 2 more, I'm now dividing it by 6. So when you divide a fraction by another number, you just multiply the bottom numbers together, the denominators. So hopefully you have 3 times x minus 6 squared, and then you square, first, make sure you kept the minus, right? If this was minus, this needs to be minus. And then you square 7/6 by squaring the top, 49, and squaring the bottom, 36. Same for this box. Okay, now I want to reduce the left-hand side. 3 goes into 36 12 times. So really I am left with y plus 49/12 equals that other side. Remember I brought that 1 down because that doesn't change until the very last step. Minus the constant from the left and the right. It wasn't y, it was f of x. Things like that matter. You're in honors pre-calculus now. You need to use the same notation the question used, so pay attention to little details like that. I have 3 times x minus 7/6 squared, and then maybe I need to do a little work on the side. 1 minus 49/12 is what I'm trying to do. Common denominator times 12 times 12. 12/12 minus 49/12. 12 minus 49 is negative, but minus 37/12. This is my standard form. Can you state the vertex quickly and easily? Opposite, so negative 7/6 becomes positive 7/6. The constant stays negative 37/12. Here is our answer. Okay, so sometimes I throw a problem in that is not in your note packet. That's why I suggest you always print your notes single-sided so you can do these extra problems on the back sides. But find a place where you can do this extra problem. I want you to write it in standard form and then state the vertex and the intercepts. I want to make sure we do intercepts as well. So I am going to completely complete the square and get this to standard form, which you might know of as graphing form, while you pause the video and see if your answer matches. So I'm not going to show any work. I'm not going to talk through any of my work. So next time you unpause the video, you will see the entire solution written out in standard form. So pause your video and go that far on your own. Okay, hopefully yours matches mine. I factored out the 2, then I did half of the middle term, which is 1. Squared happened to be 1 still. Minus the 2 in the end, and this is my standard form. You should be able to tell me the vertex. Looking in the parentheses with x, opposite gives me -1. The constant stays the same. Now it's the intercepts I want to focus on. We didn't talk about these before, but you've talked about it in integrated 1, integrated 2, and integrated 3. So first of all, one of the answers, either x-intercept or y-intercept, should be super easy. So look at the question and see if you can find either the x-intercept or the y-intercept without doing any math whatsoever. So the easy one is y-intercept. I know we just put this in graphing form. Here's our graphing form and our vertex. But don't forget the question was written in standard form at the very, very top. And this is your constant. So that is the y-intercept, right? If I plug in 0 for the x's, 0, 0, that's not 20, it's 2 times 0. That all goes away, and I'm just left with 0, comma, because that's an intercept, it's a point, 0, comma, -2. So don't forget your basic math skills. Now x-intercept. Technically, you could use either equation. So if you want to go back to that form you're used to at the top, you used to call it standard form, and do quadratic formula, you're more than welcome to. But we got it into our new standard form for a reason, so let's use that one. So I know 2 times x plus 1 squared minus 4, that's f of x. If I'm finding x-intercepts, I want to know when it equals 0. Right? Rules don't change. If you're trying to find x-intercepts, you make y equals 0. Move that 4 to the other side. I want to make the left-hand side less complicated. So start by moving things away from the parentheses. I want to make the left-hand side less complicated, so let's not multiply it out. Instead, let's divide by 2. Make the left side less complicated. Now, if x plus 1 squared equals 2, I could multiply out x plus 1, make an area diagram, and do all that, but instead, what if we square root both sides? What's the one thing you have to remember when you square root both sides of an equation? Plus or minus root 2. This is the most common mistake. Do not forget the plus or minus. And now, just to get x alone, finally, minus the 1. I understand if you want to put the 1 at the end, but it's common practice to put the -1 in the beginning. So let me show you what I mean. You might have written x equals plus or minus root 2 minus 1. That's okay, as long as your -1 is not under the square root. It just doesn't look as clean, and it's harder to tell if the 1 is under the square root or not. So it's common practice to write it the way I did on the left. But more importantly, for your answer blank, do not put a box around this. That is not the x-intercept. X-intercept is a point. Actually, it's 2 points, right? -1 plus or minus root 2, comma, 0. Make sure you answer your intercepts as points. Okay, so hopefully that helps you a little bit. Okay, another skill we're going to work on is being able to interpret word problems and solve word problems. So pause the video and read through this on your own. Make sure you understand the problem before you press resume. Once you've read the problem, draw yourself a picture of what's going on. So what does this indoor physical fitness room with a running track look like? What does the running track look like? So it tells us it is a rectangle with a semicircle on each end. Do your best to draw a semicircle, half a circle, right? Half a circle on each end. So the outside is what the track would look like. The rest of it is just how I got there. Okay, so we need to start figuring out what information we're given and what they want us to find. So A, draw the picture. Let x and y represent the length and width of the rectangular region respectively. So x and y. We're done with A. B, determine the radius of the semicircle ends of the track. Determine the distance in terms of y around the inside edge of the 2 semicircle parts of the track. Okay. Determine the radius of the semicircle ends of the track. Well, looking at my picture, I have y going all the way across the circle. If it goes all the way across the circle, it's the diameter. So then what's the radius? Radius is going to be y divided by 2, right? Half the diameter. If we keep looking at B, that's the radius, the rest of it. Determine the distance in terms of y around the inside edge of the 2 semicircular parts of the track. So they want to know what the distance along the circular parts is going to be. So if you go around that semicircle and that semicircle. Well, first let's realize if I put 2 semicircles, well, that was terrible. 2 semicircles together, what do we get? We get a circle. Distance along the edge of a circle, circumference. Circumference of a circle, you remember the equation for circumference of a circle? 2 pi r. So my circumference is 2 pi, but they don't want it in terms of r. They want it in terms of y. That means the only variable we should see should be y. Well, lucky for me, I have r defined in terms of y. So instead of an r right there, I'm going to write my y over 2 equation. Neaten this up a little bit. 2 pi y over 2, the 2's cross out. So you just get pi y. This is the distance in terms of y around the inside edge of the 2 semicircular parts of the track. So that is the green distance in our picture. So that is B. C, use the results of part B to write an equation in terms of x and y for the distance traveled in 1 lap around the track. So 1 lap around the track. I know I'm using a lot of colors. Hopefully that's helpful and not distracting. 1 lap around is going to be that semicircle, this straight edge, that semicircle, and this straight edge. So we already know the semicircles. The green parts is pi y altogether. So then 1 lap is going to be pi y plus, I just have to add this, which is clearly labeled x. And what would this one up here be? Well, it's a rectangle. That would also be x. So a lap is equal to pi y plus 2x. That's what they wanted to know. But then it says solve for y. So lap is not something I can solve for. So we need to go back. What do we know about a lap? Well, up here, a lap around the room is 200. So instead of lap, and I'm running out of room, so I'm going to erase lap. I'm going to write 200. Now take that equation and solve it for y. Again, I'm running out of room, so I'm not going to show all my math. But you would minus 2x, and then to get y alone, you would have to divide by pi. So y is going to equal 200 minus 2x divided by pi. Okay, I mean, that's what they wanted for C. It seems like they're kind of walking us through this here. D, use the results from part C to write the area of the rectangular region as a function of x. So just go back to what you know. Area of a rectangle. It was x, y, right? So the area is going to be x times y. But they want it as a function of x. That means area in terms of x. That means I can't have any y's in my equation. So this y can't be there. Look at your answer for part C. We know what y equals. Y equals this. So instead of a y, we're going to write that 200 minus 2x over pi equation. And actually, there's no reason to make that any neater than it is, so you don't need to distribute the x or anything like that. That is where we want to stop for that part. So as a function of x, done with D. E, use a graphing utility to graph the area function from part D. Use the graph to approximate the dimensions that will produce a rectangle of maximum area. So this is only if your teacher has taught you how to do this. I can't teach this in a video. So if you've learned about finding the maximum on your calculator with your current pre-calculus teacher, you would type this equation into y1, just like it is, x parentheses 200 minus 2x all over pi, close parentheses. You would sketch it, and your little window, it's going to end up being a parabola shape. You would do second calculate maximum, put your cursor on the left, press enter, put your cursor on the right, press enter, and your calculator is going to give you x equals 50 is the middle, and y equals, it's approximately 1591.549. You have to use a calculator. There's no way to do this without it. Well, we don't want you to do it without a calculator. So then the answer to the question, use the graph to approximate the dimensions that will make a rectangle that is with maximum area. Well, the dimensions are 50 by, that's, you know how when you write dimensions, you draw a little X for by. And then we need to figure out what are, sorry, I'm looking for a new color. What are too many colors? So that's X. We just found X. We need to figure out what this Y would be. Understand that Y1 is not the same thing as Y in our picture. So you can plug it into this equation. You know what X should be, so plug it in and you'll get Y. Or you know what the resulting area needs to be. So if I divide that by 50, that would also give me my Y. Either way, your dimensions should be 50 by 31.831.